Assalamu alaikum, peace be upon you guys. Today I would like to share how to take the ESP view, that means electrostatic potential view of a specific compound using Gauss view software. Actually, first of all, I would like to go. I have completed a DFT calculation using Gauss view, and then after completing a DFT calculation, after optimization using DFT theory or different kinds of theory, you'll be able to get checkpoint file and log file, that means output file. Then if you'd like to take the ESP view, that means electrostatic potential view of a specific compound, then you have to use checkpoint file that you have got after completing DFT calculation. So I would like to open my checkpoint file. Actually, I have completed a DFT calculation of 1-iodo-2,5 difluorobenzene. This is a organic compound. I would like to see the ESP view, that means electrostatic potential view, and its analysis using this compound on iodo-2,5 difluorobenzene. I would like to use iodo difluorobenzene. Actually, I have used in this DFT calculation Medix and Cambie theory and Medix functional, and I'd like to open this checkpoint file. I'd like to double click here, and if you'd like to open double click, then you'll see that automatically Gauss view window will be open. And right now I would like to see that ESP view, that means electrostatic potential view of this compound. First of all, you have to use your mouse, right button of your mouse, press any specific blank portion of this window, and then I would like to go results. After using my results menu bar, I'd like to choose surfaces and contour. And when you'd like to uh, open surfaces and contour, then new window will be open, and then you have to select cubes available. That means I would like to select new cube, where new cube, and I would like to check out total density of this compound, not alpha density or beta density or spin density or Laplacian or molecular orbital. I would like to see total density, and in total density, actually ESP view, or actually ESP view, what type of look will give you. I would like to check it out. uh, Total density here, and then press OK. When you will press new cube, then automatically you'll be able to see that your lower portion uh, maneuver, or you can say option surface actions, will be active after a minute of time. That means that when you will select, automatically uh, uh, data will be added here, and then surface actions will be active. And then I would like to use this drop down menu, and I'll press new mapped surface. When you will press new mapped surface, then automatically new mapped surface will be created, and then you can close, add views for new surfaces, contours, but I would like to close, and I would like to analyze this ESP view of this compound. When you'd like to open this molecule, it is the electrostatic potential view. Actually, in the electrostatic potential view of any compound, you will be able to see that uh, it's a blue color, it's a, you can say, red color. Actually, blue color indicates basically here, you'll be able to see that in the, it's a color color scale. In the color scale, you'll be able to see that blue color, the value of blue color is 2.881 e minus 2. It's a positive value. And in the red color portions, you'll be able to see that minus 2.881 e minus 2. That means it's a negative value of, electrostatic potential. Actually, when you'll be able to see that blue color is actually in the specific arena, blue color is, you can say, it's you can say deep blue. Deep blue means here the positivity of electron density is high. That means electron availability is low. That means you can say it's a positive center. in which easily a nucleophile can attack. And the next side of this molecule, if you'd like to see the next side of this molecule, that is actually in this portion, slightly negative color is visible. Actually, what is the meaning of negative color in this compound, in this ESPPU? Negative color means, you can say, red color means it indicates the negative value of electron. That means electron charge or electron availability is high. That's why when the electron availability high, that means you can say it's a electron rich center, and in this specific region, and easily electrophile can attack. And that's all about the meaning of red and the blue color. If you'd like to see the transparent view of this compound, then you can easily find out the transparent view of this compound. First of all, you have to select a blank portion. You have to press right button of your mouse. When you will press right button of your mouse, you'll be able to see that this kind of maneuver. I'd like to see the view, and then I would like to go display format. And then if you'd like to actually in the background portion, the background color on kind of color, but I would like to change background color into you can say white. That's why I'll select white, and then you can I would like to select OK button, and then you'll be able to see that your background color will be changed. And then if you'd like to see the transparent view of this compound, then you can select, you can go into the surface menu, and then you have to select drop down menu of format, and then if you'd like to select mesh, but right now actually this view is, you can say, solid view. If you'd like to see the mesh view, you can see mesh view, but I would like to directly see the transparent view. Mesh view means it's look like here. Actually, this is the mesh view. If you'd like to change this mesh view, if you'd like to see the transparent view of this compound, then you can select transparent, and then you'll be able to see the transparent view. And I would like to transparent it's a slider. You can maximize to opaque, actually whole. If you'd like to see the whole transparent, that's why I would like to enhance or increase this slider to the maximum point. So that's the transparent view of this compound. That means 1-iodo-2,5 difluorobenzene. Then I will press OK button. Actually, in this way, you'll be able to see actually a transparent view of this compound, and you'll be able to see that actually in which specific atom, in which actually electron rich center is present, or you can say electron deficient center is present. Actually, in this compound, you can say actually here these two atoms, in actually around these two atoms, negative color is visible. That means you can say around these two atoms actually electron deficient center is present, and in which easily nucleophile can attack. And that's all about the analysis of ESP, that means electrostatic potential view of a specific compound. And then you will be able to see that actually in this compound, which specific atom or which specific portion of molecule can take part in the specific chemical reaction. And so guys, this is all about today. And if you'd like to know, if you'd like to check it out, actually which atom is which atom takes part in the you can say electrophilic addition reaction or nucleophilic addition reaction, or you can say which specific atoms in which the availability of electron is less or availability of electron is high, then you'll be able to you'll be able to do ESP calculation, and you have to see the ESP view, and then you'll be able to confirm your which center, which atom is the main reason behind nucleophilic attack or electrophilic attack. So guys, this is all about today. Thank you for watching this video. If you have any queries, then you can share your queries in the comment box. Thank you.